That was a good introduction to where you started. Maybe you can take us back, but I just want to give you warm welcome to the channel. We're joined by François Best. He's the creator of Nux, which started off as a Next.js URL state management, but now has gone beyond Next.js with different adapters that it has. So François, thank you very much for joining me here.
Yeah, thank you for having me.
Beautiful. So we were talking about your journey. So why don't we start there? Take us back in how did you get into web development and build a library for Next.js?
So I think we started with the fact that I worked in the audio industry before, and we used to build hardware emulations in C++, so native development. And around 2016, I started to look into the web because there were a lot of new technologies like React coming out, and it felt really interesting because you could build really, really fast with it. And you could also ship really fast. Like you didn't have to package your built application into an installer, sell it to users, have them install it onto their machines, and then it's like sitting there forever. It's something that is live, the web. It's like you can always have the latest version when you hit the website that you're visiting, and you just git push and everything builds in the cloud and it's available for everyone instantly at the end of a URL. So this was the thing that really attracted me, I think, from the web platform, is this ability to ship fast and to deliver fast as well. And so I started learning a few frameworks. I landed on React in 2017 or so, just after the hooks came out. And yes, since then, I started building web applications for myself, for my clients, because I do freelance for companies and startups and other people. And I found many times that React has a state management problem. We've seen a lot of different state management solutions come up and become different over the years. And one thing that was missing is this idea of using the URL as a state manager. Because it is very convenient to put state in there that you can then share with other people, that you can share with yourself in the future by bookmarking it, that put it in your browser history if you want to navigate back through time. And it's really convenient to have a one-to-one mapping between the hooks that we're familiar with, the useState hook with this classic signature of the current value and the function to update it, and have the same thing instead of living in memory and being lost when you reload the page, live instead in the URL so that you can have something that's familiar in your code and something that's convenient that you can share with others. So it came just because I needed it in one or two projects, and I had built a variant of some kind of hook that did that several times. And at some point I decided, well, I'll just put it on NPM because I need to use it for a client project and I can't just always copy paste the same code. And some people started using it, and it started picking up steam, I think, when the app router came out for Next.js. Because at the beginning, yes, it was only for Next.js because I was only using Next.js. And it started really picking up when the app router came out, because the app router has two ways to work with URLs. When you want to update the URL, it has two modes essentially. Shallow mode, which uses the history API, which is local to your browser, and the router itself, which will send a network request to re-render the React server component tree. So you have these two approaches that also existed in the pages router with a slightly different API. It was a shallow prop in the router itself. So essentially, if you combine the two, because Next.js supports progressive migration from pages to app, so it supports applications that have both routers running at the same time, you end up with three methods to update the URL, which is difficult to scale if you have components that can live in either side of the router boundary. And so this shallow prop that the pages router had was really convenient. So because I already had an API that connected to that, I wanted to have the same thing for the app router, a declarative API that switches essentially between the two implementations and abstracts away all the logic that usually people do of stitching URLs back with the current path name that you're on just to update the URL on the page that you're on. Abstract all this logic and do it for you. And that is where it started becoming popular, I think.
That's exactly like, I feel like that's kind of how or when I came across Nux. I was using Next.js before in the pages router and React. And it's interesting that you say this kind of mindset of using or treating URL as a state holder or manager wasn't something that I or a lot of developers were not used to doing, or treating it as a place that they can hold state, giving them functionality to just save, bookmark, and share, go back in time in that same state instead of using the memory. But it became much more interesting when now you are communicating from the client, the browser, back to the server, and that is the connecting piece in the app router in Next.js, where now you are React server component first, then you are having some state on the client for interactivity, and then you can just communicate back and forth between.
You can do this parallel communication as well. It's not just client to server, it's also server back to clients. The main difference that we have now from the age of MPAs like Rails or PHP and stuff like that is that we have a reactive client. We have a client that can react to changes in the URL. So if the server was able to redirect you to another page, then we have this bidirectional link between the two that it can exchange data just using the URL as the vector of data transmission, not API endpoints or streaming responses or things like that. Just the URL itself becomes the vector of this. And it's very easy then to use the router itself to say, I want to go there and I will attach some states that you'll need at the end. So
yeah,
back and forth.
Yeah, that's interesting. Yes, from server to client is, you're right, redirects as basically your communication back from the server to the client. Besides the data or the JSON or the payload that you're sending, it's also reflected on the URL for the client to pick up from there and then continue on. Now, I mean, you mentioned that it has gone through changes from the pages router to the app router. How is it? Is it any different in the Next.js 16 with the partial pre-rendering and the caching behavior that's slightly different than the version 15?
By default, no. The stock Next.js setup hasn't changed that much. There was one big change with the introduction of async page props, like the search params page prop in the page components. Becoming async was a little change that I actually detected early and was able to react on pretty early on before the Next.js 15. But in 16 itself, no, there was not big changes. The one main big change is cache components. With cache components, there are some technical challenges in the sense that your components, essentially, when they are cached, becomes like locked in space and time and stored somewhere, and then rehydrated, not hydration, but you know what I mean, like reloaded into your server component tree when it's time to send something to the client. And anything that depends on such params is essentially dynamic. It is something that will depend on what the URL contains. You can cache some of it by making sure that whatever you're consuming as part of the URL state in that component is part of the cache key. So make sure that it crosses the right boundaries, which means that you cannot consume such params easily through Nux within a cache component, but you can do it outside and then feed it the promise that will resolve to a search param so that it can use it inside. I did some experiments with this a couple of months ago, and it worked pretty well in the sense that you could cache stuff that depends on search params, but generally speaking, if it depends on the URL, there's a good chance that it is a highlight dynamic thing. And so you're more on the rapid in suspense kind of path than trying to use cache it.
Yep.
In these cases.
Makes sense. Makes sense. So you touched on, I think, important points here. The main difference is that now promises or asynchronous tasks are now the indication for Next.js to know whether or not it should treat a component, a page, dynamic versus caching it to be static. So search params are now, you have to await them, they return a promise, so therefore if you consume them, it would turn your page into dynamic or component to dynamic, and then Nux, the same thing, if you're using that, it would turn it into dynamic unless you're using it outside and then passing it down. But again, the whole purpose here is that if your state or if your application depends on request time data, which is like typically what the search params are with the client interactivity, it should be dynamic. We are wrapping the app with the Nux provider to share that context. that becomes a client component that wraps the server component. It's not necessarily affecting whether or not it's dynamic or static. It's just that we have this interweaving of server components with client components. So that hasn't changed in Next.js 16.
It's the same donut pattern as it was before. The Nux adapter does not cause re-renders. It does not cause suspense. It's just a context provider for the client-side parts, for the hooks themselves. But every time you need to access the search params on the server, you need to go through the page props, so the search params page props, and access it from there, and then parse it from there, and then feed it to your React server component tree. But there are these two realms which are separated by the network boundary and the, what's it called? The Nux adapter provider that you put at the root of your app is essentially just for the client hooks.
Okay. What have you seen from your experience dealing with Next.js developers when they're trying to implement Nux? What is the main pain point or things people get wrong?
LLMs. I don't think it's true anymore. I think skills and a lot of the things that we've tried to help do some context engineering around this has helped a lot. I mean, even in the Nux docs, I started adding a LLMs.txt and copy as markdown, all the things you generally expect now from modern docs. But for a long time, it was very difficult to work with AI because it would hallucinate the APIs all the time. And the solution is actually very simple for that. You just load the .d.ts into the context, which contains literally the API that TypeScript is reading. So this is something that, I mean, I guess with these skills and other approaches makes less sense now because you steer the LLM into literally going to read the docs the same way a human would, in a slightly different format, obviously, but a token efficient format like Markdown. But essentially, the real source of truth is the .d.ts, the type definitions files that we ship along with the package, which is literally in your project already. It's in your node modules. So it feels like for the longest time, I was frustrated with these tools because it's literally here. You just have to look for it. Sure, it's a bit big, that's for sure. But that was, I think, one of the main frustrations I saw when people were trying to use it. As like, people don't read docs anymore because the agent does it for them. And so it is a bit frustrating to write docs when people don't read them, I guess.
Yeah.
But
yeah, I can definitely relate to that because one of the reasons why my channel, when the app router came out, I mean, there wasn't that much documentation back then, but the problem was nobody was reading the docs. I was reading the docs, creating videos, so it gained some popularity. It's because usually people don't read the docs. Do you have like an official skill for Nux on the skills.sh repository?
No, I don't have one yet because I'm working on it. And it will be part of a workshop that I'll be giving first at React Paris and then in other places. But that's the thing you get at the end, essentially, is something to give your agent. But first, you do the workshop to load your context with what you need so that you can review the code that the agent generates. Because I think it's important still for us humans, for engineers, to be able to understand what is being generated and not just vibe code everything.
Exactly. Yeah. Absolutely. But I mean, that can give enough context and point it to the documentation and give it guardrails and examples so that the LLM's generation is more so aligned with what the API is rather than hallucinating over stuff. I really like I think when you're implementing Nux in Next.js, it's super easy, super intuitive. It has the same kind of API as the useState that you have been familiar with. Found more interesting about Nux is actually going deeper and going beyond. Once you start playing around with parsers, this shallow thing that you mentioned that actually sends a request whether or not versus not, that's when the power actually shines. And I think that's the layer that many people might not even go to. They're just like using it as a surface level, replacing the useState with the useQueryState, and then using it as a state management. Take me a bit deeper into other stuff that like is still powerful and behind the scenes or different layers of Nux.
Yeah, there's actually multiple layers and it is progressive. As you say, you can start with this and this is generally how people start. And this is the demo that I do in my talks. We could actually do the demo. I have it running in the background if you want to do
Let's do it. Let's do it. Yeah.
A screen share.
Sure.
How do I share my screen? Let me just move that there. Share screen, entire screen. That one. Okay, cool. So this is what usually people do. They have a local state that lives in memory, and they want to lift it out into the URL to make it shareable. And so, as you said, it's very simple. This is how people start. They start replacing useState with useQueryState from Nux, and you change the first argument to the key that you want in the URL, so the key value store that is the search params. So count here. By default, everything in Nux is a string. So we have string or null. It's null if there's nothing in the URL. So that's going to obviously break my button here. But what we can do is tell Nux that you see how it hallucinated this /0 here. This is like, even still with autocompletion, we get, this is correct, the default value. But what we want to do is pass as integer to tell it that we're working with a number. And so if I save this now, my type is number or null. And it's more correct. This null is annoying because we have this this thing here. We can make it non-nullable by passing a default value that will be returned when something is missing in the URL, or if it's invalid. So I'll show you what it means with default 0. Whoops. 0. So now it has returned my state again. So we have this thing here. And as you can see, it works. We click the count, it updates. But it also returns the default value and null if there's no default value. If the thing is invalid, for example, if I say count equals banana, that's not a valid number, so it falls back to 0. So you always have type safety in the sense that this will always be a number. And if it's not with defaults, it will be null, and so you don't have any state in here. So we have these behaviors by default with these parsers. And a lot of people have asked me, why are you not using Zod or something like that to do that? The main reason was that in the past was that Zod did only one way deserialization, going from a string to a data type. But it didn't do the opposite. It didn't do the serialization part of going from that data type that's in your state to a string when you need to update the URL. Now it can do that with codecs and some other validation libraries like effect schema can also do the bidirectional transforms. So we need to actually have an interface that can do like an abstraction of both, like we have standard schema, but like standard codec, I guess, or something like that. That'd be cool to have that. And Nux could essentially conform to that too. But essentially what we need, the parsers are very wrongly named because they do two things. They do parsing, so going from the string that's in the URL to the data type that your application expects, and serialization the other way around when it's time to update the URL. So, and we have a lot of different parsers. You can see parse as a lot of different things.
Absolutely.
So this is like generally how you start with integer. With default 0, back to that. This is how you start with URL states. But as you said, there are ways to go much, much further than this. And this is generally how I tell people all the APIs that you can architect your application around with URL state, because it is a central part of data exchange between the client and the server. So you want to make sure that you have type safety end-to-end between client and server. It's a bit like TRPC, but going through the URL instead of going through an API endpoint. And so you want to make sure that you have the same type definitions shared between the client and the server. And this is generally the second part of the demo that I do with these albums that we can filter with the URL. So if I go to, where is it? So I'm in the app router. I've got this albums list here. And next to my page.tsx component, I can add a search params.ts. And in here, I'm going to start describing what I want, because Nux is declarative. That's the one thing that I think helped a lot as well in terms of adoption. It's the declaration in the composition. Same thing as React. That really helps think how your state composes between different pages or different components. How do you spread like a large page state into different components, or like how do you spread them together the other way around? And there is an API that I want to work on, which will make this even more fun to play with and even more clean. So it's not just ready yet, so I won't do a demo with it, but I want to show you how you can describe things. So you start with an object, we'll call it search params. And it's in this object, the keys are going to be the keys that are in the URL. So we have query, and the values will be the parsers that we describe the data type that we need. So parse as a string for this one. I'll import it from Nux server. There's I will explain actually, because that makes a bit more sense. Generally, I brush that off during my talks, but there are two imports for Nux and Nux server. If you're not using Next.js, you can use either. They are exactly the same. But if you use something that supports React Server components, you might want to use Nux server for agnostic code, because this one does not contain a use client directive, but this one does. This one has use client at the top because it exports the hooks, and this one doesn't. So you have different ways of importing things, and based on the bundlers that you use, it may or may not yell at you. Next does yell at me if I import things, because it tries to serialize the with defaults and the with options of the parsers across the client boundaries, and it doesn't work. So we need to import this from Nux server in the app router.
Makes sense.
Parse as string, I'll give it a default of empty string, and I have a release year, which is integer. Parse as integer. No default for this one. And so what we have now is a descriptor object that we will reuse throughout our application. And we can derive a lot of things from this object. And that's the value, I think, of it all. You start describing something, and then you derive useful things out of it. So we can derive a hook that we will need in these things. We can derive a loader that can pass the search params one time. And then we'll derive also a way to generate links through this. So we can start with the loader. Const load filters. Create loader from Nux. And we pass it this search params. See how it is still hallucinating things? Mm-hmm. So even with skills, even with all these things, it's just, it is hard to teach LLMs about APIs, especially if you have like a new API, a new library or something like that, or something that changes quite considerably. We've seen that they had like lots of problems with Tailwind v4, for example. Mm-hmm. They tried to still generate configuration files. Yeah. It can be tricky. And if I go to my page component, which is going to be that one, I can call this load filters with an S, that'd be better. Load filters. And I can pass it this search params page prop, which is a promise. So if it's a promise, I need to await it. We're not going to do the cache component thing of pre-rendering the outer shell and everything. But generally, you can await on either end. So you can await here, or you can await there. So you can still like preload that promise of past search params, not await it, and then pass it down to server components or client components to be consumed with views, even though that wouldn't make sense because you generally consume those with the hooks. But here we're using this to filter from our database. So I can pass those filters here. And if you look at the type, you see that it matches the descriptor object that we defined. So we have the same keys and the data types conform to the parsers that we defined. So with default query has a default of empty string, so it's non-nullable. Mm-hmm. And release here doesn't have a default, so it is number or null. Mm-hmm. And so you have this descriptor object that you can reuse throughout the thing. And so now we can already use the search, the URL bar itself as the input, because I haven't connected those inputs yet. But if I do query equals Beatles, we get the filter that gives you just the albums by the Beatles. So that works. And so now if we want to implement our filters, which are just classic inputs with a use client, we need to wrap them in suspense because the hooks will use such params internally. And when you build your application, it becomes a dynamic thing. So it needs to know how to exclude that from the tree, or at least make it so that it knows it's a dynamic API. But what we need is a hook. So we can also export a hook from this descriptor file. So if we do export const use filters, and we can create a hook that forwards this to useQueryStates, this time with an S, which deals with these such params descriptor object. So you have useQueryState singular, which is one key, one data type given by the parser, and useQueryState, which takes the object. As you start increasing the complexity of your things, I would recommend to extract those descriptions into this object and pass that to useQueryState, because you can derive a lot more than you can if you were just putting those definitions inside of the hook itself. One thing you can do generally if you're just using useQueryState is do the same thing that you generally do with React Query, is to export it as a custom hook. So if you do functions use URL counter, you move that into there and you return that. And you can use that here. And so the one thing that you have done by doing this is connecting this key and this parser in one place. And then you ensure that by reusing this hook throughout the application, you have a match between these two things. But they are still locked into this useQueryState call. And this is why useQueryStates with an S is more useful, because you can externalize the object that you use and derive more things from it. So now that we have this hook, which is where use filters here, we can consume it into the thing. And you see we have these two, this is something actually that kind of astonished me, is like we have these two imports, Nux server and from Nux, which contains use client. And I'm consuming a hook here. And somehow the bundler is able to tell that this lives on the server and this plus this lives on the client. And it's able to separate things and only bundle the right things at the right place, which is kind of amazing.
Absolutely.
Yeah, and so we can consume this use filters here. It'll be an array, use filters. And we have the same thing always, the state, which is an object, which contains these two properties. And the state updater function, we'll call it set such params, the missing API from Next.js. And we can uncomment these inputs. Now, React is going to yell at me because they're going into control mode. But already what you can see is that he has picked up the state from the URL into the input, because it's the source of truth. It synchronizes everything. So now that works. If, however, I change, why do I not have focus on this thing? That's because it's re-rendering. We good? Yeah. So if I go here and I type anything, you'll notice that it doesn't do anything because we're still in this shallow mode. This is like something I generally do an example with the counter, but I show the network tab showing that when I do this, nothing happens because Nux by default uses this shallow mode by default. It only updates on the client. The reason being that you're guaranteed to have a client running where you have these hooks that run, but you're not necessarily guaranteed to run in a framework where there is an SSR process listening for those such params. Yep. So this is where Nux becomes declarative again in the options that you pass. So we're going to pass these options here. Options from Nux. And we're going to make it optional. And we're going to do shallow false and spread the options. And by doing that, just by saying shallow false, we're telling Nux, when you update these search params, I want you to send a network request to the server because we're going to do a fetch from the database. So we need to go across the network. And so when I save this, it did that, and obviously it doesn't match anything. But if I go for Beatles, we get back what we had. Ooh, fun bug. I'll keep that one for later.
Right.
But so this is how you declare that you want to go across the network with this shallow prop. And generally, I recommend keeping some of these options in the same file so you have collocation of behavior. So you know that you're loading these filters on the server, you create the loader for it. And so you can specify shallow false at the same place so that you have like, I declare that I want to use these search params on the server. And the new API that I have in mind will make this even simpler. You can also pass these options per key. So if you want, for example, some of them to be shallow false or true, you can control it here. You have a lot of other options, like history will define whether you are pushing or replacing when you do an update. So this is good for controlling how the back button works. Limit URL updates, we'll come to it in a sec. Scroll defines whether you want to scroll back to the top of the page when you do an update. Sometimes it's valuable, sometimes it's not. I think by default it stays where it is. Shallow, we just covered it. Start transition, we'll see about that later. And clear on default is something that we will just have a look now. Let me just get rid of it. By implementing our clear button. So one way we can do this is exactly like that. We can set each individual search params to their default value. There is a shorthand. You can do null. Null means not in the URL, so it means remove from the URL when you set. But the exact shorthand for useQueryState is to set the whole thing to null, and that will clear the search params. And so now some reason it just loses focus. When I clear this, it just removes it from the URL. And something that's important to notice is it removed the what's it called? The query as well, because I set it to an empty string. If I do this, you'll see if I do just query empty string in the release here, it's not going to change much. But if I go for something like that, and I do, something's not working well with this demo, man. Clear, you see that it still removed it. I set it to an empty string and it didn't do this, which is, I think, annoying because it leaves stuff in the URL. And clear on default, which was the option that we had, clear on default, which by default is true, removes the queries that are equals to, removes the keys when it's equal to the default value. Exactly. Default. So when it's equal to the empty string, it just removes it and guarantees that you have a URL that is as clean as possible.
Okay. So there's two ways, just to summarize, to clear the state back or to reset it. One is to set it to the default, which the default option in Nux is to clear the key from the URL, but you could also set it false, so it just leaves it there with the default option. Or you can just set it to null, which basically clears everything. When it's null, it's not in the URL, so it wipes it out.
Yeah, exactly. There is a difference between the two. So if you see that if I go for Beatles, and I have set clear on default to false, and if I click clear, you see that now it keeps it like this. So in some cases, for some defaults, it might make sense to keep them in the URL because defaults can change. Like literally the value for clear on default did change. The default value did change throughout the history of Nux. So defaults can change. And so it's generally good to be more explicit than less because it makes your application more maintainable over time.
Yeah.
But by default, we try to optimize for a clean URL at the end. And one thing that I want to show about clearing as well is set search params null has another interesting property. If I go for query equals Beatles and foo equals bar, something completely unrelated, and release year equals 1967 for Sgt. Peppers. If I click clear, you'll notice that it keeps foo equals bar in the URL. Because Nux, what it does, it's declarative for just the search params that you declared. So it will only, this hook will only ever work with these two search params. It will only update those. And I think this is how Nux scales really well with composition. It allows you to use different filters, different URL states throughout your application, and they just stitch together in the URL when it comes time to update it. Mm-hmm. And so this is very nice in terms of scaling patterns.
I see.
Let's just
just going to summarize my understanding of when you're moving Nux or you want to tap into the different layers of Nux, going from the client land back into the server in Next.js, where you're now reading the search parameters inside of a server component to fetch data and then pass it to. We have this pattern of creating a separate file for our search parameters where we can define basically the schema of how our search params are going to look like. And then using that, we can create loaders, we can create hooks that are kind of tightly typed and tied into this definition that we have here. So whatever you're passing into your data fetching is already known, type safe, instead of random stuff from the URL, which is coming from the client side and you shouldn't trust it. So it gives you that pattern of now implement or using this in your server components.
Yeah, we have end-to-end type safety now between the clients with the hook, the server with the loader, and through this shared definition that they have on both sides, that the two have been derived from. So this is type safety. Now we need to talk about time safety, which is something else. Just a fancy term that I invented, but the idea is that URL is something that the updates to the URL is something that is rate limited in the browser for security reasons. Thank you, Internet Explorer. But the problem is, if you treat this as a high frequency state, you can reach those rate limits and it will maybe crash your application. Next.js is unfortunately quite sensitive to this, and it will just give you the client-side error black page if you don't have error boundaries set properly. So it's not great, but fortunately Nux, like 80% on the Nux code base, is not about type safety, it's about time safety. It's making sure that this doesn't happen by doing something simple, which is to split the update in two parts. Optimistic local state updates, that's instant. So the same way you would have a useState, it's literally a useState internally. And queuing the URL updates to be applied when it's the right time. So when the browser has had enough time between two updates. So if you have something like a slider, for example, that sends events at 60 frames a second, and you want to update the URL based on that for controls or something like that, this is something that you need to think. Well, you would have needed to think about before using Nux, but now you just use the hooks the same way, and it's just that your URL will slightly lag behind, but will be throttled automatically based on the browser that you use, because browsers don't behave the same. Safari is much slower to allow URL updates than Chrome or Firefox are, for example. And so Nux also deals with that, deals about that for you. So this time safety thing is also something that you can declaratively control through options. So the problem that we have here, I'm trying to see if there is a problem with my... I must have changed something in the setup because it keeps losing focus for some reason. I just rebooted this app like half an hour before recording, so it needs a little polish, that's for sure. But the problem that we have, if we go for Beatles again, you see we're sending one query per keystroke. Yeah. That's not great because we're spamming the server. It's great for Vercel because they get all the traffic and your bill will explode, but it's not great for us. So we need to think about how to make this more efficient in terms of how many requests we send to the server. Mm-hmm. So one thing we can do for this is to control limit URL updates. And one thing we can do for this, especially for such inputs, which you're only interested in the final value when you stop typing. What you want is a debounce behavior. Mm-hmm. So we have this debounce function in Nux. I'll set it to 250 milliseconds. If you're wondering what it does, it's a little function that generates an object that contains this method debounce and the time in milliseconds. Again, it's declarative. It's just a little bit of syntactic sugar. I could have done it like this, like method debounce and time milliseconds 250. Exactly the same thing. It's just a bit cleaner to do it like this. I have actually don't know if LLMs prefer this version or the other ones. I haven't tried it, but this allows you to declare that you want these updates to be debounced. And so now if I get rid of that and start again, if I go for Beatles and I stop typing, you see that I've sent one query with the end result, which is better. But now we have a UX problem. Because when I type, you see that nothing happened. We don't have anything, we don't have any feedback that something should happen. That's not super great, but we have, for example, I'm going to show it with a spinner that I have. Is loading, I think it's called. Yeah, is loading. That shows here when something is supposed to happen. When this is loading prop is true, we have this little spinner on the search input. And so we can try and use that to indicate that something is going to happen. I can connect that to a transition. So generally, this is how you would do optimistic UI is with a transition. Use transition from React. So this is not a Next.js thing. This is pure React. We have, is loading, set is, start transition. This is not a state. Oops, start transition. Thank you. Is loading, we can connect it to that. And so now the question becomes, when do we start our transition? Nux has actually support for start transition, so you could pass it directly here. And from there, it would fire when the network requests are being sent to the server. So this is not exactly what we want here, because we want to do like Beatles, and it will flash at the end, send the network request. And I think it's stuck there for some reason. Maybe it's my database that's having issues. Interesting. Well, that kind of kills the demo, unfortunately. But that thing is supposed to flash and then hide at the end. But what we can do is, what the problem that we want is that we want to show that our that something will happen. That when we type, we have this transition that lasts until the server has come back with the data. And what we can do for that is to wrap our state updater function here in the search input with this start transition. Yep, we can do this. Put it here. And there is a little trick to the state updater function. It returns a promise. So we can await this promise, and we can make this async. And start the transitions in React. If you pass something async, it will last for the whole duration of the promise that's inside. And this promise resolves when the URL has finished updating. Well, at least when the URL has, the request to update the URL has been sent. And if the server takes time, then it's this one that takes over for the duration that the server is running and gives you the result back. So with this combination now, we have a transition that lasts for exactly what we want. So from when you start typing to the moment when you get the data. So I don't know if it's going to work with my kind of half-botched thing, but if I go for love, no, it's still going. So unfortunately, that's not going to work well. Demo effect. If you go to my Next.js talk video, I'm literally doing this in speedrun because I didn't have a lot of time. So instead, I can try and explain one little problem that we had, which is if I clear the search params, it also takes 250 milliseconds because I've defined this debounce semantic globally for the hook. And Nux has multiple layers of where you can set options. I showed you that you can do it per key, per parser, essentially. But you can also do it at the hook level, as I'm doing here. And you can also do it at the state updater function level. So here you can also specify a lot of different options. And I can specify this one and not put it here. so that only the calls to when I update the search are going to be debounced. And that allows, for example, the clear button to be instance. That allows the year. The year should be debounced too, I guess. Anything where you type essentially should be debounced. And things like sliders and high frequency inputs where you're only interested in the final value. But this cascade of options allows you to be super precise in how you want to control the behavior that you want in a declarative manner. Because here, for example, this would debounce all the time. But if I clear the input, I want that update to be instant. And so what I can do is trigger on the value that I set. If it exists, I debounce. Otherwise, I don't. So you can choose whether or not, you can choose how you control the application in the URL declaratively based on some logic. And it's, I think, really, really useful.
Okay, great. All right, so let's pause here. I want to summarize what we have done so far. So we are talking about time safety, which is how do you actually make these updates? The first part was that Nux is automatically queuing your updates on the client side using the history API so that it doesn't crash the browser. That's something we don't have to worry about, but Nux has that built in, so it works well with the browser. The second part of it is, now if we are inside of a framework like Next.js, where this URL updates are going to fire off requests to the server, we want to debounce those requests. So we use the debounce function that comes in Nux to limit how we're updating or how frequently we're updating the URL. Then the problem came that, okay, now we're delaying, so we're not sending like frequent requests to the server. Now we want to show the user that something is happening. We use the start transition hook or the use transition hook from React, which is the concurrency API from React, to now say, all right, there's something happening. But the start transition, when you just pass that to Nux natively supports it, you pass it there, so it uses that same start transition, shows the loading UI, but that initially is only for the server side, but you want the user to actually see something as soon as they start typing. So then you can use that same start transition in the state update function and hook it up with the search input. So as soon as they start typing, that start transition or the state update shows the loading, and then the server kicks in to actually fetch the data and returns it back. So you have like a better UX, even though you are limiting the amount of requests going to the server.
Exactly. That's exactly that.
Perfect. I have used start transition and hooked it up with the states here, but I didn't know that you can actually go into the deeper level. What I loved it from your talk now is actually going into the hook level, to that specific state level, to that specific input level, and actually pass those options. So you have granular control over every basic key that you have or state that you have.
Yeah, exactly. Yeah. I mean, one thing that we can't do at this level is choose which key would have which option. So here, for example, I'm setting just the query. This is also something that I see people do. Quick tip, if you use the state updater function for useQueryStates, just like useQueryState and just like useState in general, it also takes the old value and can return an object. Don't do this. Don't spread the old thing. It's not necessary because Nux will only update what you pass it. You can do a partial update. I'm just setting the query here. I'm leaving the release year alone. And when I update the release year, I do exactly the opposite. I do just the release year with the number check for, because it's a number input that you get the value passed as a string for some reason. No, value as number. But yeah, no, we need to check for nans, because if you like empty it, it becomes nan, which is annoying. But if it's emptied because it's nan, you pass null to clear it. That's what we do here. But you see, I'm only passing release here in this case, and I'm not touching at all the query, which is something that's really frustrating to do with stock Next.js APIs, because you have to always stitch all the things that you want to update the URL. Whereas Nux, being declarative, you only update what you want to do. And it already has the state for the other things, and it already knows what to update. And so it will do all the stitching with the current values, optimistic or not. And this is where the time safety also plays, is like all these debounce semantics. Debounce was kind of complex to put in place because there are a lot of cases where you want to cancel that debounce update. For example, if the user navigates away to another page, you don't want to apply that queued URL update to the wrong page. So there's a lot of intricacies in making sure that when you play with time, you have ways to cancel out the things that you scheduled in the future. And so, because on top of debounce, we also have throttle, which does exactly the same thing. But throttle is like you send it once, and then every time frame you send an update, rather than just pushing it back to the end. But we have the two, and so you have
Can you explain the throttle? I didn't get what the throttle does.
Okay. If you have a discrete control, like the button I had before, that is a throttle. It's best to throttle that. That means the first time you click it, imagine like the thing is idle, has been idle for a while. Nothing happens. You click the button, you want this event to be sent immediately. But if you click it very, very fast, you want those updates to be sent at a regular frequency that is slower than the rate at which you click. And so that is throttle. You send an update, and then you wait a little bit to send maybe another one if there have been events between the two updates that you sent. Whereas debounce, you send an update, you want to do an update, you don't send it right away. You wait for 250 milliseconds in my case, and if there haven't been any other updates in that time, then you can do the update at the end. So you delay the time when something will happen. And if you have multiple things, every time it pushes the moment when the update will happen. It will happen exactly 250 milliseconds after the last time you sent an update.
Got it. I think the correct me if I'm wrong, but the good example for it is if you have a button for a counter and the user pushes it multiple times, you want to actually update the state for the exact number of times that the button was pushed. Just throttle it so it's not firing off, but you want the exact number of button pushes that happen or clicks that happen. Whereas in the search input with the debounce, you're not actually sending those intermediary requests. You're just waiting for the final result and then just firing that one off.
In case of throttle, you would also potentially skip some values in the URL because you're sending updates at a regular frequency. So throttle gives you regular updates, whereas debounce gives you eventual updates. But if you press it a lot of times in between, you would probably go from 1 to 17, then 35, then something like that. Like every time there is an update being sent, it sends the current value that it's at to the server. So it would not send 1, 2, 3, 4, 5 delayed in time, because that would essentially DDoS your server over time. But it would still send the same amounts of network requests, but it would take much longer. Instead, what you want is this update that happens instantly on the client. So you do 1, 2, 3, 4, 5. And then so the one is sent first in throttle. And then at the end of the throttle time, if your counter is now stable at 5, it will send the update for 5. So there are two different semantics that you can choose which one to makes more sense for your application.
Cool.
What else can we talk about? There's one more thing with all these things. So now we've seen how to control type safety across client and server, and we've seen how to control time safety. We haven't gone all the way in terms of type safety because there's one more thing that we can do with this. It's generating links to a page, because now we're using the URL as not only a state manager, but a way to inject state into a page when we load it. And so we have this favorites section here that will show us things like that. And if we look at how they're done, they're just simple links to my album with a prefixed, pre-filled query. So if I do that, it just matches. Metal gives me Metallica. And so the problem that I have here is that they are hard-coded, and that's not type safe. So how do we make this type safe? Again, we derive things from the source of truth, which is our descriptor object. So we can do export const get albums link, I think I called it. And now I'm going to use something that is not actually part of Nux. It's something that you should see and install in your application, which is called get type safe link. Typed link, create type link, that's how I call it. Because it uses the typed routes API from Next.js. So it's a way that to have a type safe set of all the path names in your application. So here I'm interested in /albums, and I can pass this search params descriptor. And now this has created a strong bond between this path name and this set of search params. If we look at how it's done internally, it's using this route type definition, which comes from the Next.js dev server or build server when you build for application for production, which contains all those things. So we have slash with potentially a query string or a hash, albums with all the combinations of the things that are valid for this route. And we bind this with the serializer, which is like the opposite of the loader. It allows you to create types, it allows you to capture type safe sets of states and then gives you an href string at the end. And it also takes this serialize function. It also takes a first argument, which can be a path name or something to apply those search params to. And in this case, what we can do is bind it to this route. And the reason why we vendor this is like we need access to this type, which only exists in your applications. I can't really have that in the Nux package. But there is a SHADCN registry item that you can use to install this into your application and tweak it as you need. And that will work for this page. And so this function now is bound to this path name and these search params. So type safe linking end to end essentially. And if I use it in my favorites, I can replace this with get albums link. And now I only have to specify the search params. And the AI can actually be helpful sometimes. Oops. Except when it doesn't close the brackets. There we go. And so now the output hasn't changed at all. I mean, if we look at the what's it called? The URL that will say, it's literally the same thing, but it is type safe in the sense that if you do something, it will just yell at you. Or if you do 42 here, it just, no, this is a string. This is not. So this allows you to have literally end-to-end type safety between linking, loading, and the hooks, which are essentially the way to do both at the same time in a reactive manner.
Yeah.
So that allows you to do that.
Pretty cool. So this last part of it is kind of replicating what Next typed links are, that just basically based on your router give you type safety for all the path that exist in your application, but you're extending it now this way to the search parameters. So that it ties a specific schema that you've defined for your search params to a specific path. So whenever you want to create the link, you just use this function, pass the object for the parameters, and it yells at you if you're passing a state or the key that doesn't exist in your kind of search params schema. Yeah,
exactly. And the thing you do, because I generally specify my search params next to the page, so at the page level. Here I am in the albums page, in the search params for this albums page. I know that I'm on /albums, so I can already have this in there, abstracted away and like locked into this function. And so whenever somewhere in my application I need to link to that page, I can call this function, just pass the search params that this declares, and it generates the right link for this page.
Absolutely.
So this is the one thing that it doesn't support yet is dynamic params. So if I had like /album / something here, this is something that I need to look into because it would be a bit more tricky to do, but not technically impossible, because you just need to be able to pass the path name arguments, the path name fragments, I think they call it.
Yeah.
And the search params separately, because in many cases, some routers get it wrong. The pages router does get this wrong. Is like they put everything in the same bag, the URL params and the search params. And if you have two of the same name, they conflict with each other, which is kind of, problem in API design, I guess.
Yeah.
You want to have these two really separated. Like they are different things. URL params make more sense for some things. Search params make more sense for other things. They have different purposes.
Absolutely. So I really like this pattern that you're using, creating your search params file right beside your page that defines the search params for that React server component page that helps you data fetch and create all of this like helper functions for you to then manage the state on the client side, set the state, load the search params and whatnot. And you're using the useQueryStates, the plural that just creates an object. Even for like when you have multiple states, you're always using this object kind of notation instead of having to use multiple useQueryState like the singular. You're just tying all of them together. My understanding from useQueryStates outside of this pattern was you would typically use that for states that are related to each other, like lat long for coordinates and stuff. But here in this pattern, it's best if you're using that object. You can then, when you're updating, you're still updating that one state that you want to update, so you don't merge into the other ones. You just leave them alone. Just update the one that you have. Is that like a correct pattern that I summarized?
Yeah. In the docs, I do always take this example of latitude, longitude because it's short in terms of, and it is short and it helps understand how search params can relate to each other. But it also kind of hides the fact that you don't always generally have one search params. When you start having UIs like this, with filters, with table states, with pagination, with ordering and things like that, like sorting, not ordering. You see what I mean? You generally have a lot of different states that can live in the URL. And a lot of them are related in a way. Like they don't always move together, but they are kind of related in a unit of feature. Like they all belong to a table in your page, or they all belong to some controls for some UI elements in your page. And so describing them in these kinds of objects allows you to do all these things. And you can derive even more things from it. You can derive types. So you can do export type, album search params. It's not return type. This is something people would also do because I guess AI just suggested, but there is a type helper, which is inf parser type from Nux, type of search params, and this gives you the same thing that we saw for the filters, the same thing that is returned by the loader, the same thing that this will accept, and the same thing that is the states returned by useQueryState.
Yeah,
so you have this infer, a bit like Zod, where you can pass it again, this kind of thing, and it will be able to give you types if you want to define types somewhere else and use this as the source of truth.
Yep, exactly. So you use that kind of schema, you can infer types from it.
It is a schema. It is a schema, exactly.
Yeah.
It is very similar to a Zod schema or something like that.
Absolutely. You can infer types from it. You can create loaders from it. You can tie your hooks into it. You can create links from it that just makes it type safe. So this is a better pattern even if the states are not, like in this case, they're all affecting our search filters, but this pattern of using the useQueryStates and having them all in one object, it unlocks all of these features that now you could use in your application.
Yeah.
Awesome. This was great. I think a great deep dive into how to use Nux or how to use it like a pro because beginner stuff is like what you see most people use, just replacing for useState, but now this is a whole different new level, which is actually very necessary for Next.js developers because Next.js with the app router with the server components, you would want to do all of this.
If you want to use it as a pro, there's one more trick that I'm going to show you if we have time.
All right.
It's how to remap keys so that they can be shorter in the URL. Because you see I have this query love release here in the URL. Those are kind of verbose.
Yeah.
And these are short. But imagine you have something complex and you want to have these variable names be meaningful for developers, meaningful for the self-documentation of your application. You want these to be potentially long, but you want your URL to be short. The URL is limited in size. You generally want to keep it under 2,000 characters to really be safe everywhere. And so Nux has this way of remapping those keys declaratively. We can do something called URL keys, which is going to be typed as URL keys of type of search params. So now, whoops, before you spoil the fun, it can show you, autocomplete goes too fast sometimes. It can show you that, it is bound now to these two things, so you can not mess it up. Okay. But what you can do is remap them to shorter values. So
Q and Y, yes, yeah.
Q and, well, we could do Y, yes, I guess.
Yeah.
Let's not be too optimistic. But what we need now is to tell all these things that I exported about this new mapping. So I do this with URL keys, pass it here, and pass it, I think it's an option here too. Yeah.
Which is basically another option we can provide to Nux to say, just like the other options, like URL shallow keys and whatnot, we can pass in the URL keys, which is a mapping of what we want to name them.
It lives in a different place, though. This one only exists at the hook level, and you pass it to the create whatever feature that you derive it from. But for the hooks, it's not something you can specify in the state updater function, for example, because it doesn't really make sense. At this point, you are only working with those those variable names. You see that I haven't changed anything else in my code. Everything else will use the variable names throughout. But now when I click this link, you see that it pre-fills my URL with these shorthands, and I can go and do Beatles and not type correctly. There we go. And so it maps now to this Q thing, and we now have this shorthands remapping of URL keys.
Beautiful.
And if you want to go even more pro with all these things, there's one thing you can do, which is define your own parsers, because I'm using the stock ones for now, and I don't really have a use case for this, but I can create a const custom parser equals create parser from Nux. And here you can specify two functions. So you have parse, which takes the value as a string that's from the URL. String, there we go. And so here you could do a value.split that, value.split dot, I guess we split it like this, we get string array. Imagine, for example, if you want to do a sort thing, like if you wanted to have something like this, you do sort by foo ascending, something like that. Okay. So you have two values, you have two pieces of information in the value. You have the ID that you want to target, and you have the direction. So if you want to do something like this, you could do something like split that into two parts. So you have ID and direction. You return an object that conforms to this, ID, direction. Generally, if we've conformed to 10-stack table, I think they do desk as a Boolean, so direction equal desk, for example. But now it yells at me because we need the counterparts, how to transform this into a string. So we have to do serialize ID at desk, and we get this as string or undefined. We want to make sure that it's not undefined. ID any, that should be a string. Okay, that's fun. Why are you saying value.split? Yeah. All right, well, I must have a problem with TypeScript in this demo too. And so here you get the value and you remap it to a string. Okay, so it was just that this was not returning the right thing. Okay, so we have a string, we have this, and now our custom parser, if we want to do, I'll just define it above so I can put it here. I can do a sort, exactly. I can define a default sorting option. And so now if we look at the type, I've removed the type, unfortunately. But if we look at the type search params, no, not return type, infer parser type, again, we see now that we have this sort as an object that returns our things. So we have defined a little piece of code that we can reuse throughout our application that will define how to deserialize and reserialize our things. There's a little more, one more thing that we need to define for this actually, because we have something that is not referentially equivalent. We have an object. So we need to define an equality function to make sure that we check if two things are equal. And this is checked for when you set to the default value to make sure that you reset it properly.
Okay.
So when you do like custom parsers, generally you specify these three things: parse, serialize, and equals. And from there, you have like, the world is your oyster. You can generally generate a lot of different ways of representing data in the URL. It's like a custom renderer for the URL, essentially, this thing. And Nux then just gives you this this kind of object afterwards. So you just work with objects, and then it will go through the serialization process. And when the URL updates, it goes through the parser and gives you all you need. So yeah,
I love that. So we have built-in parsers in Nux when dealing with strings, numbers, integers, booleans, literals, dates, enums, and whatnot. But you can also create your own custom parser. You define how to parse, how to serialize, and how to kind of do the object reference equality to say when does the state actually has changed, when it hasn't. Don't look at the reference object. Look at this A dot value and B dot value to just enable you to create custom parsers and do whatever you want with your state, which is very powerful.
Yeah. This is also something that you said, well, what not annoys you, but like what friction do you see? It's when people tend to use just string, like parser string as the default, when what they accept is something narrower than a string. And this is where parser string literal shines. It's like it gives you a way to pass it a set of options that you want. And the values that you will have are literally literals of these things. So you have it here, like it gives you ascending or descending when you pass these two values. So narrow your states as much as possible. This is part of validating the inputs. So you want to make sure that you can't pass something like banana in here. That makes no sense in your application, that it will either crash or have some weird defaults that you don't know about. It's like better to consider the URL as something untrusted, because that's what it is, and validate as much as possible using those parsers.
Beautiful.
Yeah.
Love that. Man, I thought I know Nux, but I have learned a lot of new things now
there's
today.
Probably a few. There's probably a lot of more things that I haven't covered. Like I haven't covered testing. I haven't covered custom parsers, stuff like custom adapters.
Yes.
When you start going into testing, this is where things start becoming fun. I think I have filters.test. Yeah, I have the file. I'm not going to run everything because there was a bug and I was showing how to fix it live on stage. But essentially, you have this Nux testing adapter, which allows you to render your components that use Nux inside of vtest or Playwright and stuff like that. And allows you to both do assertions on it. So you make sure here, for example, that I'm starting with a set of search params, and I just make sure that my elements have picked it up. But you can also do URL update spy functions. And when you act on your UI, make sure that the URL is updated. Updates to the URL have been sent with the right values. So you have these three essential parts of testing: setup, act, and assert. I never remember the three A's, what the first one is. Arrange, act, and assert. That's the one. The one. So you can do all three with the Nux testing adapter.
Cool. Very cool. Maybe we need to have you for a second part, François, to do.
Maybe, yeah. When I have the unified API, which is essentially all of these things that I'm showing here, all these 1, 2, 3 exports plus the type plus everything, it'll just be one export. And once this is polished and everything, yeah, I'm happy to come back to show you how it works, because this one will be sweet in terms of composition, in terms of extracting things to manipulate them.
Yeah.
It'll be much smoother than trying to find names for all these things and how to spread them. And yeah, it'll be much simpler.
Simpler.
That's for sure.
I can imagine. Definitely. I'd love to have you back here.
Yeah.
Well, all right. This was quite a session. Well, thank you very much. I guess we can, there you go. I'm sure there's going to be questions. So like always, folks, I would recommend dropping them down in the comments. Maybe we would summarize all of those questions. Exactly. We would have François back hopefully for a second session with the unified API, or build common use cases, patterns and whatnot, answer questions. Thank you very much, François, for taking the time and joining me here. I learned a ton.
Thank you for having me. Always happy to talk about all these things and try and spread the word about useState.
Thank you again, François, for joining me. And that was a wrap. I'll see you in the next one. Bye-bye.